Hello friends, in today's video I would like to focus on this topic called simply supported beam. If you have any doubt prior to any concept related to simply supported beam, I would like that you kindly go through the previous videos where I had given a quite sufficient information. In today's video, I would like to focus on this simply supported beam and how where we can calculate the reactions from a simply supported beam. To start with, I will define the simply supported beam as a beam where the total load that comes on the beam is supported by the two external supports. Now for the example, the below which you are seeing, that is AB. Now this AB is a simply supported beam. Now I will show you as to how we can calculate the support reactions from a simply supported beam. So this is the problem you can see here. Now here this AB is a simply supported beam where the point A is a hinge support. As I informed you earlier, if point A is a hinge support, then definitely it will have two reactions where VA and HA are the two reactions. And there is a inclined load at B which is at 30 degree. Then between C to D there is a UDL of 20 kilonewton per meter and the point D is a roller support. You can analyze by the entire reaction by yourself. So what is the first step? Now my first step here is I need to know as what is the total number of reactions in this beam. Now for this point A, since it is a hinge support, so I am having two reactions, VA as well as HA. And for the roller support VD, I am having one reaction. Now what do I do on the next step is I am converting the inclined load at B into vertical and horizontal components, or I am resolving the inclined load at B into vertical and horizontal components. How? I have converted this inclined load at B into Fy. Its Fy means its sine component. The moment when I convert into the vertical component, it becomes 100 into sine 30. And the second component becomes the fx component. Now fx component here is 100 into cos 30. At the same time, you can see the UDL, which was acting between C and D, has been converted into point load by using the formula 20 into 4, where 20 is the I should say the uniformly distributed load intensity and the 4 is the span. So here it has become into 20 into 4, which is 80 kilonewton point load. Now I'll explain you as to how I can calculate the reactions. So now I'll focus on the calculation part. So these are the calculation parts as we can see here. The first I'll focus on submission fx is equal to 0. Now regarding this, if anyone has a doubt, I would like to inform you that summation fx is equal to 0 means submission of all the horizontal forces acting on this beam is equal to 0. If you have any doubt as to from how has this condition has come, so these are the three conditions which we normally apply on a static body such as beam and column. Static means those bodies which never have any motion in them, neither in the horizontal nor vertical nor any moment. So going by the first condition, it says submission fx is equal to 0, which means submission of all the horizontal forces acting on the beam is equal to 0. So where I have assumed the left to right direction as positive. Now coming back to the diagram, you can see now in this condition I'll focus on the horizontal forces acting on the body. Now this is the first horizontal force HA, which is going from left to right, and 100 into cos into 30 is the next force which is acting in the horizontal direction. So this I will apply in this reaction, where I'll say that HA minus 100 into cos 30 is equal to 0. Thereby I am solving, and I'm got the value of HA is equal to 86.60 kilonewton. So that was the first reaction which we have solved in the simply supported beam. Now coming back to the next reaction, which is VA and VB. Now coming, just have an analyze in the problem. You can see that again here VB and VD, they both are vertical reactions. So after submission Fx equal to 0, I'll focus on the next condition, that is submission Fy is equal to 0. So again here what I assume is that I am assuming that vertical upward directions, means all those forces which are acting in the vertical upward direction are positive, and the forces which are acting from top to bottom are as negative. So going by this formula, I'll say that VA minus 100 into sine 30 plus VD minus 80 is equal to 0. So when I solve this equation, I get two unknowns V and Vd, and the combined known value is 130 kilonewton. So that forms my equation number 2. Now going by the third equation, which is submission of moment at any point A is equal to 0. See, the actual condition summation of moment at any point, but if you see, coming back to the problem, at point A I'm having two forces VA as well as HA. So the moment I take moment at A, so these two forces become 0, and I have the only third component, that is VD. So for three unknowns, I have three equations. Okay, and from the two starting equations, I have made two values, and the last point is my VD. So again, I'll come at this point, that is submission of moment at A is equal to 0, assuming clockwise direction as positive. So your C is 100 into sine 30 into 2 plus 20 into 4 into 6 minus Vd into 8 is equal to 0. So in this, I get the values 100 plus 480 is equal to Vd into 8. Therefore, solving this equation, I get the Vd value of Vd is equal to 72.5 kilonewton, and the value of Va comes to be 57.5 kilonewton. So in this entire problem, I can say you that I had three unknown values, that is HA, VA and VD, and which I solved by having the equations submission Fx equal to 0, submission Fy equal to 0, and the third equation was submission of moment at A is equal to 0. And from these equations, I have got the values of HA, VA and VD. I hope this video had solved the problem of simply supported. I would request all the people who are watching the video to kindly press the like button and kindly suggest me as to what should be my improvements in the next lecture. And I would like to state that in my next lecture, in the same pattern, I would like to show you as to how we can calculate the support reactions for a cantilever beam. Thanks a lot for watching the video. Thank you very much.